All right, let's talk about the vertex of a parabola. I'm just going to draw some generic parabola right here. And it is symmetric, even though it doesn't look like it. All parabolas are symmetric about the center. And there is this point here at the very bottom, which we call the vertex. This is the point we're interested in for any parabola. So I've got the generic form of the equation of a parabola, y equals x squared plus bx plus c. And we want to find the x and y coordinates of the vertex. Well, when x equals to 0, then that leaves us with y is equal to c. Sorry, wow, I drew a 0. Y is equal to c. Because when x equals 0, these two terms go to 0. And when we have x equals 0, y equals c, we end up with this point right here, which is the point 0, c for any parabola. Okay, that is really helpful, but that still doesn't get us very far along the way of getting the vertex. So let's manipulate this value c and see what happens. Anytime we change this value c, we get a vertical shift of our parabola. It will not move horizontally in any way. So we can move c. Let's set c is equal to 0. What will that do? Well, I'm just going to grab this parabola, and I can move it now, to the point where, something like that, where I've now moved this point down to c equals 0. So we have a 0, 0. And now the vertex is no longer at the same y coordinate as it was, but it's still at the same x coordinate that it was right here. So this x value, where my dotted line is, has not changed with this vertical shift. And this is going to help us to leverage some properties of parabolas to help us solve the equation for the vertex. So now we've moved through a vertical shift by changing c to 0. We've moved this parabola, which gives us the new equation for the parabola, ax squared plus bx, and we've set c equals to 0, so that's what we have now. So let's factor this and solve for the two roots. We have another root here. We already know the one root because we just made it be at 0, 0, but we have this other root that I've drawn here in green, and let's figure out where that is. So I'm going to factor x. So I have x times ax plus b. And now I know I have two roots. One is where x equals 0, and the other one I have to solve this equation, ax plus b equals 0. So I'm going to subtract b from both sides. I have ax equals negative b, and I'm going to divide both sides by a, so that I have x equals negative b over a. So now we have the point here, negative b over a, and y equaling 0. I'm going to clean that up a little bit. That's kind of ugly. Ooh, wow, moving all over the place. Okay, so now we have the two roots of our parabola are lined up for us, and this is really getting us a long way into finding the vertex, because we know that one side of this line, if I'm to draw a line from here to here, this side is at 0, and this is at negative b over a. So the length of the line is negative b over a minus 0, or just negative b over a. And the center point of that line is at 1/2 the length of the line, or we take negative b over a. Wow, I'm already writing the 2 here. And we just divide, I cannot even think here, sorry. We divide by 2. And that is going to give us negative b over 2a. This is the halfway point between these 2 points, so I'm going to draw in red. This point here is at negative b over 2a. X equals negative b over 2a. Okay, so we have done a vertical shift of our parabola. to force it to go through this point right here, we found this root and found that the center, this dotted line, lies exactly half of this x value of that root. So that gives us the x coordinate of our vertex. I'm going to go ahead and move this back. Let's see, I don't remember exactly. Oh, I do have that point. So something like that, back where it was. And I'm going to erase some of this mess that I've created now and clean it up a little bit. And then let's draw in what we know about the vertex. So we know that the vertex is at the point negative b over 2a, and we don't know the y value. This is pretty easy to find. We just need to solve this equation here when x equals negative b over 2a. And we're going to leave the c in here, and we took it to 0 so that we could force the parabola to kind of live down here so that we would be able to find this x coordinate of the vertex. Now that we're finding the y coordinate, we need to leave the c in there because that's part of the original equation. So I'm going to go ahead and solve it. So we have the original equation, and I'm going to put x equal to negative b over 2a. So I have negative b over 2a squared plus b times x, negative b over 2a plus c. And let's solve this, and we'll just take a few steps to do that. So we have a negative here, but we are squaring it, so a negative times a negative is a positive. So that gives us a b squared over 4a squared. I'm adding the b here, but we have a b times a negative here. Oops, sorry. So we're going to get a negative b squared over 2a plus c. And let's simplify this. We can cancel this a with one of the a's over here. So we have y is equal to b squared over 4a minus b squared over 2a plus c. I'm going to go ahead and multiply this term by 2 over 2, which will give us a common denominator here. This will be 4a. So we can add these. So that means that y is equal to b squared over 4a minus 2b squared over 4a plus c. And now I can add these two terms together, which gives me my final equation of negative b squared over 4a plus c. So I have a y value now when x is equal to negative b over 2a, this point here, I get a y value, which is here. So we can update this now to the final answer, negative b squared over 4a plus c. This is the vertex for any parabola of the form, well, all parabolas are of the form y equals x squared plus bx plus c. So you give me any parabola and I can find the vertex. Now you might be thinking, hang on a second, you solved this with the parabola in quadrant 1. What if the parabola is somewhere else? So let's just look at that real quick. I'm going to just draw another coordinate axis here, and we'll draw a parabola. Let's put the parabola here. So instead, the vertex is now over here instead of somewhere over here or over here that we had before. So how does this change anything? Well, it doesn't. We're going to move so right now my y-intercept is right here. So this time, instead of taking c from a positive value to 0, I'm going to take c from a negative value to 0. And that's going to move this parabola up to here. So I'm moving this point, here I'll do it in a different color, I'm moving this point up to here by setting c equal to 0. And that gives me two x-intercepts again. I have this one here. This will be at negative b over a as we solved before. If you look back at our solution, we got x equal to negative b over a here. By setting c to 0, which is where this is a plus 0 here. So we set c to 0 and we solved for the roots and we got an x equals to 0 and x equals negative b over a. So here in the same thing we have in this one, where we have one root at x equals 0 and another at negative b over a. That gives us this place here is negative b over 2a, just as before. This works if the parabola is facing in this direction. It's the same thing. I have, here, let me draw that a little bit better so we can look at the intercept. So if I have this one here, then I have the y-intercept is located here. I'm just going to do the same thing and move that y-intercept here, which will move this point that is on the same horizontal plane. It'll move it up to here. And that will be my root that I'll be solving for, which will be at negative b over a again. And then this center line will be exactly halfway through between those two, and that's at negative b over 2a. So always this is going to pan out for us just the same as it ever did. And we'll just go back to this example here that we looked at. And note that the transformation that we did was a vertical transformation, which doesn't change the x coordinate of the vertex. And we were able to obtain that value. We plugged that value into the original equation, including the c. So with c equal to whatever it was, and we get this final answer. Let's just look at one more example, and that's going to be kind of this. Okay, this equation that we're very familiar with, y equals x squared. So that's a parabola that we know sorry, that's not exactly at the vertex, but let's say that it is. Okay, we know the vertex of this one is at 0, 0. So we already know that. Let's just check our solution to see if it's going to work. So we could rewrite this in the form 1x squared plus 0x plus 0. So that means that our a is equal to 1, our b is equal to 0, and our c is equal to 0. So we have the x coordinate of the vertex is at negative b over 2a equals 0 over 2 times 1. Well, anything times 0 is equal to 0. So that pans out for us. We know that our x coordinate is at 0. Our y coordinate is at negative b squared over 4a plus c. And again, we have b and c equal to 0, so both of these terms are going to go to 0, and this is just going to equal 0. So in the case where y equals x squared, we have both coordinates going to 0, and that's what we would expect. You can try this out on your own with any parabola and verify by plotting it that your answer is correct.